Hey, welcome back to our graduate statistics course. This is week 12, and this is our last lecture video for this week. We'll do a third regression problem, and the reason I want to do this additional one, it's because I want to play around. We'll do two more actually, one in order for you to think about how regression might work with categorical variables as predictors. So the response variable has to be continuous, but your predictor variable could be either continuous or categorical. I want to give an example of a situation where a categorical predictor is at play. So poverty versus region. Is there a relationship between poverty and the region, and the particular region a particular state is from? So here is the model. You have poverty equals 11.17 plus 0.38 region colon west. So let's understand what this is. Here you would have something like this when our explanatory variable is categorical, and the way we code it will affect how we're going to make the variable show up in the model. The reason we're doing region colon west is because we're coding the east region 0 and the west region 1. So when we're trying to predict poverty for the east region, this term will go to 0 and will disappear, and the intercept becomes the prediction of poverty for the east region. When we want to predict poverty for the west, we would keep this on and add 0.38 to 11.17 in order to predict poverty. So for eastern states, one more time with filling, we plug 0 for x. This is what would happen in the equation. Oops. And again, you would have the intercept itself, because this term goes to 0, as the prediction for poverty in the east states. So we call the particular level of the categorical variable that we code as 0 as the reference level, right? And then we ask, how much can I expect poverty to change when I go from the reference level to a different level? In this case, we just have 2. So it's the difference between the reference level and one other level, which is west. So for western states, we're going to plug 1 for x. And here we have poverty equals the intercept plus 0.38 times 1, and that's 11.55. So poverty is about 0.38 higher in the west compared to the east. So the model intercept predicts an 11.17% average poverty in eastern states, because we're setting this to 0. This is the value, because the interpretation of the intercept, right, is the value we get for y when we plug 0 for the explanatory variable. Here 0 is meaningful because that means east, right? We coded east as 0. And the slope of the model predicts that the average poverty percentage in western states is 0.38% higher than in eastern states. Apologize for this interruption. So now let's move on to a situation where you have more than 2 categories. We'll play with a new region variable, region 4, that has 4 levels: the northeast, the Midwest, the West, and the South. And the exercise will be to write the linear regression model based on the regression output above. So when you run a regression model where you're entering as predictor the variable region 4, and as response variable the variable poverty, R will spit out an output that will look more or less like this. We see the intercept, and then we see the we see 3 of the 4 levels of the variable region 4 here represented. We see Midwest, we see West, and we see South. That means that R picked the Northeast as the reference level because it's not here, right? It means that it picked it to have the 0 estimate, right? The 0 value. So it doesn't matter the estimate here. So that's the reference level. And the important thing to think about is that these estimates are, it should be interpreted as how much poverty in each individual region, how much poverty in each of these 3 individual regions differ with respect to the reference level, right? The reference level, which is the Northeast, the estimate of poverty there, you should think, is the intercept. Why? Because this will be 0, this will be 0, and this will be 0. So when I multiply these particular coefficients by 0, they'll all be 0. So this is the poverty estimated for the Northeast. Poverty in the Midwest will be 0.03 higher than that. In the West, 1.79 higher than that. And in the South, 4.16 higher than that. So now let's explain this in a different way by writing out the equation. Let's see how this would play out. Percent poverty, hat, which means predicted, equals the intercept, plus 0.03, region 4 Midwest, plus 1.79, this value here, times region 4 West, plus 4.16 times region 4 South. So you can imagine that if I need to predict something for the Northeast, this will be 0, this will be 0, and this will be 0, because these values here would be all 0. So this is the value for the reference level. If I need to predict something for the West, say, this would be 0. This would be 0. And that's why I can say that for the West, it will be 1.79 plus 9.50. So it's, 9.50, we know it's what happens in the Northeast, the reference level. So I interpret this 1.79 as the amount that I'll have to add of poverty if I go from the Northeast to the West, because the other 2 are 0. So I'm always comparing with the reference level. So again, the reference level, how will you know what R picked? You will know because it will not appear in the output. And in this case, it's Northeast. All right, so let's calculate the predicted poverty rate for Western states. Like I just talked you through, let's actually do it. So we'll call 0 this term because if you're West, you can't be Northwest. You can't be Midwest. We'll call this 1. So this number will go into the prediction, and we'll call this 0. So what we have in the end is 9.50 plus 0, because this particular term here will go to 0, plus 1.79 plus 0. So the poverty level is 11.29, which is exactly 1.79 greater than what is expected in the Northeast. So that's it for today. We learned quite a bit. We learned about correlations and how to assess correlations using we didn't call it that, but it's the Pearson's R correlation, which is what you use when you have 2 continuous quantitative variables. Then we learned how to kind of add information to describing that relationship through actual modeling of that relationship with the equation of a line. We learned how to make predictions using the equation of a line, and we've done so both with numerical predictors and with categorical predictors. So now we'll practice some of that in the lab. So I'll go through the guided activity as usual with you, and you will have an independent activity this week to work on and prepare for very soon doing your final exam. All right, see you then. Bye-bye.